Now, so what is this? I think, actually, I bet everybody in the room kind of has some sense that the shape of the data is important, but let me go through the examples here. So here, this is a situation where algebraic modeling is appropriate. So the data has the shape of a line, and the line goes through there. And in this case, the algebraic methods are entirely appropriate and are exactly what one should use. They give us kind of maximal compression and, you know, really good understanding. But then there's this kind of situation where there's no line that fits at all, but cluster analysis is really important here. And let's just phrase cluster analysis in a particular way. Namely, we'll phrase it as approximating the data set, not by a line, but by a discrete set of 3 points in this case, or n points if I have n clusters. So here too, cluster analysis is also the approximation by a shape. Now, Kepler's data, if you remember, for a planet circling the sun, will give you kind of a looping model like this. And there's ad hoc methods for that. But in this case, the idea is to approximate by a loop. And that loop may not be necessarily circular as it is here, but it might be elliptical or whatever. But we're already in a little bit of a bind here, because before we have good methods for approximating by lines and by discrete sets of points, but we don't really have quite the same thing for, you know, loopy data. We might go ahead and build a whole technology around that. I'm sure that we could, but we might be worried about it because of an example like this one. So now at this point, what you see is something that has more of a Y shape to it. You know, so it's kind of flared. And at this point, we say, well, do we want to build a detector for Ys, for a letter Y, a Y detector, if you like? Well, philosophically, we have to ask ourselves, do I really want to do this? Do I want to have a long list of possible shapes and a bunch of algorithms for each of them that are specific to each of them? Or do I want a methodology for modeling that can handle all shapes all at once? Because I know for a fact that I'm going to hit more complicated and different things from these three. Okay, and so that's kind of the idea of topological data analysis.